So what do I mean when I say indeterminate form? Now, hopefully this is something you've encountered already because you've been doing the homework and encountered instructional material and been reading the book and watching videos. Regardless, an indeterminate form is when I get something like 0 over 0. This like really problematic thing that could be anything. I could get infinity over infinity. I could get infinity minus infinity. I could get 0 times infinity. I could get 0 to the 0. I could get 0 to the infinity, and so on. So there are lots of different ways that functions can manifest and reveal any of these, and all of them can be masks behind which hide anything. And so our objective when we find indeterminate forms is to peel away the mask by applying algebraic techniques or graphical techniques to help understand what's going on. What I want to work through in this next set of content here are these 7 problems, and I'm going to label them. And I'm going to ask the question, is the limit an indeterminate form? And I'm not worried about what the value of the limit is. I'm worried about asking the question, is it an indeterminate form? So that's what I'm working on at this particular moment with you. And I'm going to set up the first one and work through the first one with you right away. So when I say is it an indeterminate form, I mean, if I plug in the point of interest, x equals 5, do I get one of these things? So I'm going to plug in x equals 5. I'm going to get 5 minus 5 over 5 plus 5. That's like 0 over 10. That's just 0. That's just, ain't no problem there. That's just 0. So even though I do get 0 in the numerator, 0 in the numerator is not problematic. It's just 0. It's 0 in the numerator and the denominator that's problematic. So in this particular case, I find for this one, no, not indeterminate form. Let's do B next. Let's do B next. We'll focus on this one. Feel free to go ahead and try plug in 0 for x and see if we get one of the problematic indeterminate forms. So we're working on B, the limit B, and we're asking the question, is an indeterminate form? So to answer that question, I'm going to plug in x equals 0. And I'm going to get minus 4 plus 0 squared minus 16 over minus 2 times 0. That's, let's see here, minus 4 squared is 16. Uh-oh. And when I say uh-oh, I'm saying it for dramatic effect. It's not actually a problem. We can work through it. 0 over 0. Yes, limit B is an indeterminate form. That doesn't mean the limit doesn't exist. That doesn't tell us what the value is. That just means that I'm going to have to do more work. Let's do this one down here. Let's do that one in the bottom left there. I know it's a one-sided limit. I would suggest you just plug in 0 for now. If the numerator is 0 and the denominator isn't, or if the denominator is 0 but the numerator isn't indeterminate form, the answer is no. This is not an indeterminate form because only one of the numerator and denominator were 0. Let's move on to the next one. Focusing on this one. We should be plugging in 4 for x. X equals 4. And we'll have 4 squared minus 28 plus 12 over 4 squared. I'll put in 16 minus 8 minus 8. Uh-oh, things are looking bad. Well, and I say bad, it's not bad. Things are looking 0. Yep. 0 over 0. 0 over 0. So yes, indeterminate form. At which point, I don't know what the value of the limit is. I don't know what doesn't exist. I don't know what exists. Right? It could be 1. It could be 5. This could be negative 13. This could be infinity. This could be minus infinity. This could be does not exist. It could be literally anything. And so I've got to apply additional techniques in order to figure out what it is. Let's do E. Let's do E. Is the limit E an indeterminate form? Again, there's no cost to being wrong. Worst case scenario, you're wrong, and then we talk through the answer, and then you find out what the right thing was and why it was the right thing. All right, here's what I'm going to do to answer this question, y'all. I'm going to plug in x equals 5. And we'll find I have root 2 minus the square root of 5 minus 3 over 5 minus 5. That's root 2 minus the square root of 2 over 5 minus 5, 0 over 0, indeterminate form. Should we do F? Let's do F. Let's do F. Focusing on this one right here. Paying attention to this point. All right, so I'm going to plug in x equals 0. 0 minus 3 over 0 cubed times 0 plus 5. That's negative 3 over 0. It's not indeterminate form. Instead, this is going to be some form of infinity minus infinity or does not exist. So make sure that we've got 0 in both locations, not just in the denominator. If you only have 0 in the denominator, then it's going to be infinity, minus infinity, or does not exist. We know it's going to be one of those three things. Last one. Let's do G. Plug in x equals 3. 3 plus 3 over 9 plus 9. That's 6 over 18 equals 1/3. Not indeterminate form. Let's play a little what if, shall we? What if we are interested in x going to minus 3? Is that indeterminate form? Check out what it does to the numerator. At x equals minus 3, we'd have negative 3 plus 3. Okay, so we've got the 0 there, but in the denominator, I'd have negative 3 squared plus 9, which is 0 over 18. That's just plain old 0. So the answer is no. I put that problem on this set specifically because it kind of has the structure. You know, I've got like thing that looks like it is a common root because I've got like a thing and I've got like things squared down here. But I moved us away from the place, and furthermore on this problem, I put a plus instead of a minus, just to kind of further, I don't know, poke ya. Get those juices flowing. I hope that you found this a useful exercise to see 7 different problems that all require some sort of, you know, like, gotta like plug it in and see what happens. I hope that you will eventually get to a point where you can just look at a problem and see whether it's indeterminate form or not.